Okay, this is your video on molar conversions, specifically dealing with formula weight. This is very similar to the last video where we were looking at molar mass and molar conversions of just simple elements, but now we're actually going to be dealing with compounds. So in this video, nomenclature, right, naming compounds is going to be very important because you're not going to be given any formulas. You're going to be given just names. And as you'll soon find out, if you don't have the right formula for the name that you're given, then you're not going to have the right formula weight or molar mass, as you'll soon see. Right? So in this video, we're going to do a formula composition review. Okay, just kind of talk about what a formula is and how they are composed, whether they be, ionically bonded or covalently bonded. We're going to talk about calculating formula weight, which is pretty simple as long as you have the right formula. And formula weight, as I mentioned right here, is just the molar mass of a molecule or a compound. Okay, so pretty much if there's more than one atom there, then we have a formula weight because there's more than just one element. Okay, and then lastly we have some dimensional analysis examples of using formula weight in our class. Okay, so the first thing we're going to do is do some review. So if I was to take two compounds, right, I'm going to pick one. I'm going to pick this is going to be PCl3, right? This is phosphorus trichloride. Okay, this is held together covalently, right? It consists of one phosphorus and 3 chlorides or chlorine atoms, right? So if I wanted to say I have 36 molecules of phosphorus trichloride, okay, how many atoms of chlorine? Oops. There. Right? How many atoms of chlorine are there? And hopefully you realize that's a simple dimensional analysis. I start with what I'm given, 36 molecules of PCl3. I put that over 1, right? And then I know that in every molecule, right, and I don't see a conversion factor right here. I don't see an equivalency statement. This is my equivalency statement right here, right? It says there's 3 chlorines for every one of those. So I have 1 molecule of PCl3 has 3 chlorines, right? Of course, that causes my molecules to cancel out. I'm left with just chlorine. So my final answer would be 36 times 3 is 108. In this case, I'm going to make it easier on me and just go 36.0. So we have sig figs. 108 chlorine atoms, right? Atoms. And that's a simple dimensional analysis when trying to determine how many atoms are in certain molecules, right? If I was to give another one, right? Let's go ahead and try with, actually I'm not going to give you the formula as you won't really have the formula. I'm going to give you an incorrect spelling of the word nitrate. There we go. So, copper 2 nitrate. What's the formula? Okay. This is where nomenclature becomes important, because if I don't have the right formula for this, I'm not going to have the right ratios in my compound. So, if I do it, copper, right, and I know nitrate is NO3, and copper 2, and each nitrate is -1, right, because copper 2 means copper is 2 plus, nitrate is -1, right, so that means I would need 2 nitrates in order to make this compound neutral, right? So, what do I have here? I have, in this formula, 1 copper. In this formula, I have 1 times 2, so 2 nitrogens. I have 1 copper, 2 nitrogens, and oxygen, I have 3 per nitrate, but I have 2 nitrates, so that I have a grand total of 6 oxygens. Okay, that looks like a 60. Let's space those out. 6 oxygen atoms. Okay, so 1 copper, 2 nitrogen, and 6 oxygen atoms in one, what we call a formula unit of copper nitrate. Or copper 2 nitrate. Why do I call it a formula unit? It's because I can't call it a molecule, because this is held together by ionic bonds. This is an ionic compound. So ionic compounds, like we remember, they're held together by ionic bonds. Ionic bonds are not actual physical connections between the two atoms, so there is no bonding, so to speak, to form a molecule. Okay, there's just an attraction between the ions. So we call ionic compounds formula units. Okay, so what I want to know here is, what if I had 215 formula units of copper 2 nitrate, which is CuNO32, and I want to know how many nitrogens are there. Okay, same deal, right? 215 of, so formula unit. Yes, you may abbreviate. Okay, but I'm going to go. Oops. 215 formula unit of copper nitrate, okay, over 1, and I know that for every 1 formula unit of copper 2 nitrate, I have 2 nitrogen atoms. So, after do that, I end up with a grand total of 430 nitrogen atoms. Okay. Pretty simple, right? Okay, so that's the review of formula units and of the composition of how compounds are, or what the compounds look like, and what do they mean, what do those numbers mean. Okay, so moving on to the meat and potatoes of this video, and that is formula weight, which another word for formula weight is molar mass. Okay, it's pretty simple. Sodium. So I didn't have sodium. Let's not go sodium. Let's go with let's stick with phosphorus trichloride. Phosphorus trichloride, right? I want the molar mass of that. Well, as it turns out, remember, we had 1 phosphorus and we had 3 chlorines, correct? Well, the molar mass of the entire formula, or what we call the formula weight, is the sum of all the molar masses of the individual atoms. So, for example, phosphorus has a molar mass of 30.97 grams per mole. I'm going to add that to 3 times 35.45 grams per mole, which I get from the periodic table for chlorine. Okay, I add all those together and I end up with 137.32 grams per mole. This is the formula weight, or the molar mass, of phosphorus trichloride. Okay, so pretty straightforward. What I'd like you to do is, for copper 2 nitrate, I would like you to give me the molar mass. So pause the video and do what you're supposed to do. Okay, give me the molar mass of, or formula weight of, copper 2 nitrate. Okay, so hopefully we realize, remember, 1 copper, 2 nitrogens, and 6 oxygens. So I'm going to go first with the copper, which is 63.55 grams per mole. I'm going to add the 2 nitrogens, which at 14.01 grams per mole each. And then I have the 6 oxygen atoms at 16 grams per mole each, and I'll get a grand total of 187.57 grams per mole. Alright? Now, these are exact numbers to the point where you do not apply sig figs when calculating your molar mass. Just take the values as they are in the periodic table that is given to you and keep all the digits. Okay, so this would be the molar mass of copper 2 nitrate. So, question is, what can I do with this molar mass? Well, you can do the same thing with this molar mass that you can do with the molar mass of the individual atoms, right? So you can convert to convert from moles to mass. You can convert from mass to moles. You can convert from formula units or molecules to moles, or formula units and molecules to mass. You can go in both directions, just like you did with the individual atoms. So let's go ahead and do a couple of those examples, right? So let's say I had, I want to know how many molecules of phosphorus trichloride in 4.2 moles of phosphorus trichloride, right? So how I would set that up, I take what I'm given and put it over 1. 4.2 moles phosphorus trichloride. Put that over 1. Okay? And I want to know how many molecules there are. Well, guess what? A mole is a mole is a mole. So if I'm going from moles to molecules, or molecules to mole, or moles to formula units, or formula units to mole, I'm still using Avogadro's number. Okay? So in this case, I'm going to go 1 mole of PCl3 is 6.02 times 10 to the 23rd. In this case, molecules of PCl3. And if I was to do that calculation, I end up with 6.02 with 2 sig figs is going to end up with 2.5 times 10 to the 24 molecules of PCl3, right? Because my moles cancel out. Simple enough. Okay. Of course, it gets a little trickier when we start dealing with mass, but nothing that's beyond your comprehension. So let's go ahead and take a look at one. I want to know, what is the mass of 2.46 moles of the copper 2 nitrate? Okay, so I start with what I'm given, which is 2.46 moles copper 2 nitrate. Yes, I want you to write all these things out. Okay, over 1. Get in the habit, folks, trust me. And then I know that for every 1 mole of copper 2 nitrate, there is 187.57 grams of copper nitrate. If you're wondering, how did I get that number right there? Easy. If I go back a couple slides, I calculated the molar mass. All right, so you take copper, 2 nitrogens, 6 oxygens, add them all together, you end up with 187.57 grams per mole, and then I can use it, as I have here. So if I take 187.57 grams, and I divide that, or excuse me, I multiply that by 2.46 moles with 3 sig figs, I end up with 461 grams of copper 2 nitrate. Why? Because moles cancel out. Grams copper 2 nitrate. Okay? Which, like I said, that makes sense. This right here is about 2.5 times 1 mole, and if 1 mole is 187.57, then it would be about 2.5 times larger than 187.57, which is 461. Okay? If you can start seeing things like, oh, what kind of answer should I be looking for? Should I be getting a big answer? Should I be getting a little answer? That will help you understand what's going on. If you don't have the ability to kind of to foresee what your answer should look like, then talk to me so I can help you. Okay? So let's go ahead and try another one. Let's go with, I want to know the mass. What do I want to? How about the molecules of 27.9 grams of the phosphorus trichloride. So here is mass is involved. I'm going to use molar mass. Molecules are involved. I'm going to use Avogadro's number. So take what I'm given, put it over 1. 27.9 grams phosphorus trichloride. Put that over 1. Okay. Now, suggestion, you can do the whole, if you guys remember the A equals B and then B equals C, and therefore A is not a triangle. A equals C as well, right? You can do that if you want to, but I'm going to go ahead and do it with an extra step, okay? Just so you guys can see my thought process. So I'm going to go grams. I know that the molar mass of phosphorus trichloride is 137.32 grams phosphorus trichloride for every 1 mole of phosphorus trichloride, okay? And then I also know that for every 1 mole of phosphorus trichloride, I have 6.02 times 10 to the 23rd molecules of the phosphorus trichloride. Okay, so if I'm looking at this, moles cancel out, grams cancel out, I'm left with molecules of phosphorus trichloride, which is what I want. And here we go. I'm going to go 6.02 times 10 to the 23rd, okay, equals times 27.9. That equals that value divided by 137.32. And I end up with 1.2 with 3 sig figs, 1.22 times 10 to the 23rd molecules of PCl3. All right, so take a look. Does this make sense? Well, a mole weighs this much. All right, I don't have that much, so I must have a number that is less than a mole, which means I need to have a number that is less than 6.02 times 10 to the 23rd, and hey, this is less. Okay, obviously, there's a lot of numbers that are less than 6.02 times 10 to the 23rd, but hey, at least it's a start, right? If I end up with a number of, 3.65 times 10 to the 43rd, okay, something went wrong. But hey, this number does check this little barrier for us, so we are at least aware that the answer should be less than 6.02 times 10 to the 23rd. All right, let's go ahead and knock one more out. I know it's a lot. Let's go knock one more out. I want to know the number of, here's a good one. I want to know the number of atoms of oxygen. No, let's not. Let's stick with nitrogen. Atoms of nitrogen in 5.23 grams of the copper 2 nitrate. Okay, this one's a little heavy, but not too bad. Right, I'm going to start with what I'm given. I put it over 1. So 5.23 grams, okay, copper nitrate over 1. And I need to go to moles. That's usually the place to go. If I go to moles, I'm good. Okay, so I'm going to go with this copper nitrate is 187.57 grams of copper 2 nitrate. Is 1 mole of copper 2 nitrate. Okay, and then for every 1 mole of copper 2 nitrate is 6.02 times 10 to the 23rd formula units of copper 2 nitrate. Of course, I'm not done here, because if I was to continue on, I know that for every 1 formula unit of copper 2 nitrate, I have 2 nitrogen atoms. Okay, so yeah, little longer dimensional analysis, but nothing beyond your control, right? So grams of copper nitrate cancel out, moles of copper nitrate cancel out, formula units of copper nitrate cancel out, and I'm left with nitrogen atoms. So I do my math, and I end up with 6.02 times 10 to the 23rd times 5.23 times 2, that, and I'm going to divide that by 187.57. My final answer, first of all, I'm thinking about this. Now, the more steps you have, the harder it is to do your little double check, but it's still possible, right? If I know that 5 grams of roughly 5 grams of copper nitrate is well below the molar mass, right? I should have well below 6.02 times 10 to the 23rd atoms of nitrogen, even though there's 2 nitrogen atoms in every formula unit. But my answer with 3 sig figs ends up being 3.36 times 10 to the 22nd atoms of nitrogen. Okay? On the calculator, it shows up as 3.357. Well, 3 sig figs, I need to round that 5 up to a 6. Okay? Like I said, long video. I know it's a lot there, but this is the beginning of something big. So a long video is sometimes warranted. All right? If you guys have any questions, leave a comment, send an email, ask me in class.